In this video, we're going to go over some vector math. Now, in the previous video, we went over the difference between vectors and scalars. We did a little bit of trigonometry to find hypotenuses, and we also used trigonometry to find the direction of the vectors. So in this video, we're going to go over the different ways to use vectors for the different math purposes of this physics course. All right, so the first thing I want to show you is how to do vector math using like the drawing techniques. This is what we call the tip to tail method. Tip to tail. All right, now there isn't a reason why we would use the tip to tail method over like a mathematical method other than the fact of the situation. Okay, so both methods are exactly the same and they're both great. All right, so tip to tail method, let's come up with an example first. So let's say we first walked 12 meters to the right, right? And then we stopped a little bit, and then we walked 8 meters to the right. All right, so let's say there's a word problem, and I'm asking you to use the tip to tail method to find out total distance that you walked. So in order to do this, we're going to have to create two vectors. The first vector, we'll call this vector A. A is, I'll put this up there. Oops. A is 12 meters to the right. Okay. And now I'm going to draw B. And we know that B is going to be 8 meters to the right. So let's draw that right underneath of it. Now, because these are vectors, make sure your secondary arrow is smaller than your the first arrow. So the tip to tail method, what you have to do is you have to draw your first vector. So this is vector A. So equals, right? So you have to draw vector A, and where vector A ends, okay, at that arrowhead, we're going to draw vector B. So we draw vector B right here. Okay, so that's the way that we visually represent vector addition. Now, what this tells us is that the total length or the total distance that we traveled right here, okay, we can call this mystery vector C. Okay, so if I were to ask you, well, how far did I walk, right? You can say, well, 12 plus 8, Mr. Lee, that's easy. C is therefore is equal to 20 meters to the right. This is simple. All right. Well, what about if we have tip to tail, but with vector subtraction? Okay. So let's do the same scenario. We'll have vector A be 12 meters to the right, but instead of going 8 meters to the right, we're going to do 8 meters to the left. Okay. So same thing. I'm going to create both of my vectors. So this is A, and A is 12 meters to the right. And then we have B, which is right there. All right. This is 8 meters to the left. All right, so if we add these two together, so the tip to tail method still follows. Let's draw A first. So this is A, okay? And right underneath of it, I'm going to show you B. So we start where A ended, but I don't want to overlap there. So I'm going to just draw it right underneath here. So where A ends, I'm going to draw B. B. Now, the difference between the two, okay, so where you started to where you ended, that's the important part. So where you started here to where you ended here, this is C, okay, and this is a resultant. And so the way that we could write this is A plus B gives us C, okay? And so if A is 12 meters to the right, okay, plus 8 meters to the left, this is equal to C. And see what I do here. I can even write it like this. So anything to the right or up, we say is positive, and anything that is left or down, we say is negative. We can even write it like this. Will give us C. So the answer would be, well, how far are you from the start? Okay, so from the start to where we ended, that shortest path is C, and that will be 4 meters is vector C. Okay, and because this is a vector, remember this answer needs a direction. You might be thinking, well, Mr. Lee, why don't you write the direction here? And if we look at the arrowhead, right, so we started at the start, and our arrowhead goes or points to where we ended, so in this case to the right, this would be 4 meters to the right, right? But remember what I said before, if there is no direction there, it's assumed that whatever is in front of here tells us the direction. And so this is a unwritten positive. So that positive tells us that we ended up to the right. But let's make this most definitely correct. Positive 4 meters to the right. Yeah, we're covering all our bases there. All right, no room for ambiguity. So that's the tip to tail method. So the next thing I want to show you is how can we do these in a 2D or maybe even 3D form. So 3D drawing is a little bit more difficult. So let's do some 2D drawing. All right. So I'm going to do a Cartesian plane. So we're going to do a simple one, and then we're going to get a little bit more complicated, right? Let's do A first. So this is A, and you might have guessed it, A is 12 meters long. All right, and we have B. Watch what I do. I'm going to draw B a little bit differently, okay? So this is B right here. And the reason why I'm drawing it like this, by the way, B is 9 meters up. Okay, the reason why I'm drawing it like this is so that I can show you how to get these two vectors and rearrange it so that we have tip to tail. Okay, so even though these two A and B are vectors, if I were to do tip to tail, okay, this is A plus B. And remember, you start the addition where the other one ended. So A ended there, so I'm going to start there and go up. And this is B. Now, the resultant, which in the previous video we called it V, would be from where you started. So I started right there at A, and I go to where I ended. So I ended right there at B. So this is my vector, and this is C. Okay, so in this case, this will be 15 units at, what was it, like 36-ish degrees. All right, so that's how we can do tip to tail using the 2D method. All right, so let's get a little bit more advanced. It won't always be that straightforward. So let's do both vectors that are at an angle. Okay, so we're not going to do this mathematically. Well, I guess we could, right? Yeah, we can do this mathematically. Okay, so let's do, we'll call this vector A, okay? And we'll call this here vector B. Okay, I'm going to make it a little bit easier for us. I'm going to use 3, 4, 5 triangles, okay? Meaning that my vector components, so this is the x component of vector A. Let's make this 4, and we'll make this the y component of vector A. We'll make this 3, okay? And then we'll just reverse it for B. We'll say that this x component of B is 3, but 3 to the left, right? So negative 3. And then this y component here, B of y will be positive 4. Okay, so if we were to do tip to tail, right? So let's do tip to tail first because that is the skill that we're still practicing. Okay, I'm going to draw A first, and I'm going to draw B first. So as you're following along, so we have A there, and then I'm going to draw B right there. Okay, so this is B, and this was A. So the resultant would be from that connection point to there. So I'm going to start at the beginning of A, I'm going to end where B ended. So this would be C. Okay. Now, this is how you would use the tip-to-tail method. So if the question is asking what is, let's see here, what is A plus B? Right, we know it's equal to C, but numerically now we can figure it out. All right, and that comes with the component addition. So let's take a look over here. We're going to go into the hat notation. So we know, let's break apart vector A. So we said vector A is, we said it was 4 I hat plus 3 j hat, and we said that vector B, if we take a look over here, is equal to negative 3 I hat plus 4 j hat. So if we were to add these two vectors, what we have to do is just add all of the x components, or the I hats, and we have to add up all of the y components, or all of the j hats. And so if we add A to B, we're left with, let's see here, so we can say A plus B is equal to 4 I hat plus 3 j hat minus 3 I hat plus 4 j hat, right? And all this is equal to 1 I hat plus 7 j hat. Okay, so this is what C is equal to. So what this tells us is that this vector C that we drew using the tip-to-tail method, that right there, this goes out 1 unit to the right, and it goes up 7 units in order to create vector C. Okay, so in order to visually show vector addition, we use tip to tail, but in order to mathematically show vector addition, we can use this hat addition method right there. Okay, all right. And the only thing left for you to do is to figure out the direction of angle C, and so that's good practice. So at this moment, just pause the video real quick and try to get the same answer that I do. All right. So if we take a look at C, what we're looking for is this angle right here. Okay, that mysterious angle for C. And so because we have the opposite side, which is J, and the adjacent side, which is the I, we can use the inverse tangent. So opposite side is 7 over 1. And I'm going to use my calculator to figure that out. And let's see here. We get inverse tangent of 7. And that is 81.87 degrees. All right. Yeah. There you go. That's vector addition. See you next time. Bye-bye.